Hello everybody, we are starting a new section today and we'll be looking at dividing radicals. So we've looked at adding and subtracting radicals. Remember, when we add and subtract radicals, we make sure we have the same junk in our trunk, the same radicand, and we add or subtract our coefficients. Then we looked at multiplying radicals. When we multiply radicals, we first multiply our coefficients and then multiply our radicands. And then finally today, we're going to look at how to divide radicals. I compare dividing radicals to simplifying fractions. So there's a lot of kind of like seeing what those multiples are. So let's dive into it. How do you divide a radical? First, you want to break the radicand up using the quotient rule. So if I have the square root of a over b, or the square root of a fraction, I'm going to break that radicand apart to where I have a separate radicand in my numerator as well as my denominator. Once I break that up, I can look for those perfect square radicals so I can simplify it and get rid of my radical. After you get rid of that radical, you are going to simplify until you just have a radical on the top or no radical at all. So we're going to dive into what happens if we get a radical in our denominator in a bit, but let's first practice dividing radicals, just in general first. So I have that example at the bottom. I have the square root of 49 over 100. My first step is to break that up into the square root of 49 over the square root of 100. Luckily, those are both perfect squares, so I am just going to simplify and get rid of my radical because the square root of 49 is 7 and the square root of 100 is 10. Booyah! All right, let's look at some more examples. Example number 2. I have the square root of a fraction of 8 over 32. Pump the brakes real quick, because instinctively, when you get to this process, you want to immediately break apart that radical. But before we do that, it's going to be easier for us in the long run if we look at that fraction and see, hey, can I simplify that fraction within the radicand? Is 8 over 32, can that be simplified? The answer is yes. So if I just had the fraction 8 over 32, that can be simplified down to 1/4. So that would simplify down to the square root of 1/4. Now I'm going to go through the process of dividing radicals. So now I can break that up to the square root of 1 over the square root of 4, which simplifies down to 1/2. If you look at the example above, if we would have broken that apart, we would have gotten the square root of 8 and the square root of 32, and those are not perfect squares. We would have eventually gotten down to 1 over 2, but it would just take more work. So within this process, look at your fraction. Say, hey, is that fraction, can I simplify that? Then move forward. So looking at example 3, I have the square root of 3 over 16. Can 3 over 16 be simplified? No, it cannot. So now I'm going to go through my process. So I'm going to break up that radicand into square root 3, square root 16. Square root of 16 is a perfect fraction, or not a perfect fraction, a perfect square. So I break that up into square root 3 over 4. And that's as simple as I can go. All right, let's look at example number 4. I have the square root of 12 over the square root of 36. Here, it's already broken apart for us. So we already have that step. My job is just to simplify those radicals. So I'm looking at those radicals and I see, okay, 36 is a perfect square. So I can simplify that down to 6. Is the square root of 12 a perfect square? No, it is not. However, does it have a perfect square that's a multiple? Yeah, 12 can be broken up into 4 and 3. So I'm going to break apart that radical into square root 3. Actually, I'm going to put my 4 first. Square root 4 multiplied by square root 3. Now I take it a step further and I take the square root of that 4, which gives me 2. square root 3 over 6. Can anything else in that equation be simplified? Well, yeah. 2 and 6, think of that as a fraction. That could be simplified. So I'm going to divide both of those by 2 to give me square root 3 over 3 as my final answer. So use dividing radicals, you're really pulling a lot of those previous math skills as far as simplifying radicals, simplifying fractions, seeing what those multiples are. Okay, let's look at another example, another little challenge problem. Example number 5. I have 4 square root 15, 3 square root 27. All right, looking at that right away, can any of that be simplified? Can my coefficients be simplified? Can I simplify that fraction in the front? Not at this moment. Can the square root of 15 be simplified? All right, let's think for a second. Okay, let me make my list of my multiples of 15. 1 and 15, it's not divisible by 2. It is divisible by 3. So 3 and 5. But none of those are perfect squares. Okay, let's look at 27. What are my multiples of 27? 1 and 27, 2 and 3, or not 2 and 3. 2 can't go in the 27. 3 and 9, excuse me, 6, 4, 5, 7, 8, none of those can go in there. Okay. Does 27 have a perfect square? It does. Okay, so I'm going to break apart my 27. And let's see where this goes. So if I simplify this down, I have 4 square root 15 over 3 times square root 3 times square root 9. Okay, that square root 9 simplifies down to 3. So I'll have 3 times 3 to give me 9 square root 3. Okay. Am I done there? No, I'm not. Okay, because I can actually get rid of some junk in my numerator. How can I do that? Well, it's going to be the square root 15. Remember how when we were doing exponents, if I had the same stuff on top as the same stuff on bottom, I could cancel it out? We're going to use that same property here. So I'm going to divide up my square root 15 into 3 and 5 so I can cross out or cancel that radical in my denominator. So I'll have 4 multiplied by, I'm going to divide up my square root 15 into square root 3 times square root 5. And if I bring my stuff that is on the bottom, my square root 3's will cancel out. Now I'm fully simplified. So I have 4 square root 5 over 9. So sometimes breaking up those radicals, you'll think, okay, I can only break it up for perfect squares. Well, that's not always the case. When dividing radicals, you can break them up so you can reduce some of your junk on the bottom. All right? The next component of dividing radicals is this process known as rationalizing the denominator. Unfortunately, we cannot just leave our radicals in the denominator. That is a no-go. It's not fully simplified if there's a radical in the denominator. So we use this process called rationalizing the denominator. How do you rationalize it? Well, you multiply both the numerator and the denominator by the radical in the denominator. So there's this process. When you multiply a radical by itself, it gets rid of the radical. So for example, if I had, square root 2 multiplied by square root 2, my answer would be 2. I simply get, multiplying those together cancels out that radical. Okay, let me show you another example with a perfect square. So let's say I had square root 16 multiplied by square root 16. Well, both of those simplify down to 4 times 4. What's 4 times 4? 16. So that's why whenever we see a radical multiplied by itself, we can just kind of get rid of our root, and it will just leave us with our radicand. And that's how we rationalize the denominator. So let's look at this example. I have 4 divided by the square root of 7. Looking at that, I can't really simplify any of the stuff within it, except I cannot leave that radical on the bottom. So I'm going to multiply my top and my bottom by square root 7. That will cancel out my radical in the bottom, leaving me with just 7. And at the top, I have 4 square root 7. That's my final answer, and that's simplified. So it's basically just rearranging your problem so you do not have a radical on the bottom. If you type both of those answers into your calculator, you would get the same decimal number. It's just rearranged. So you should never have your final answer be with a radical in your denominator. Okay, let's look at some more examples. Find each quotient, write your answer in the simplest radical form, meaning no radicals in my denominator. I have square root 5 times or divided by square root 2. In order to get rid of that square root 2 on the bottom, I'm going to multiply those by my denominator. So square root 2 times square root 2. Those square roots cancel out, leaving me with just 2 on the bottom. Whenever I multiply radicals, I multiply my coefficients, and then I multiply my radicand. So I would have the square root of 10. Can square root 10 be simplified any further? No, it cannot. No, it cannot. Okay, so my final answer would be square root 10 over 2. All right, let's look at example number 8. I have the square root of 6 over 18. Can that fraction be simplified? Yes, it can. 18 divided by 6 is 3. So this would simplify. Before we even look at rationalizing it, it was simplified down to 1/3. My next job is to break up my radical. So I have square root 1 over square root 3. Are any of those perfect squares? Yes, my 1 is. So I would just have 1 over square root 3. I cannot leave my radicand in the denominator. So I'm going to multiply both of those by square root 3. Square root 3. So my final answer would be square root 3 over 3. And there you have it, folks. Okay, let's look at another one. Example number 9. I have the square root of 81 over 2. Can that fraction be simplified? No, it cannot. So I'm just going to break it up. That breaks up into square root of 81 over square root of 2. Square root of 81 simplifies down to 9. So I have 9 over square root 2. I cannot leave that like that. I have to rationalize it. So I'm going to multiply that by my denominator, square root 2 over square root 2. That gets rid of my root, leaving me with 9 square root 2 over 2 as my final answer. Okay, one more problem. Challenge 1. Find each quotient. Write your answer in the simplest radical form. I have square root 3 over 2 square root 8. Okay. My first job is to see, can I simplify any of that at all? Yes, I can. 8 can be broken apart. So I'm going to break this up into square root 3 over 2 multiplied by square root 4 multiplied by square root 2. That 4 simplifies down to 2, leaving me with 2 times 2. So that will finally simplify down to square root 3 over 4 square root 2. Now that that's simplified, I need to get rid of that radical in my denominator. So I'm going to multiply those by square root 2 over square root 2. I'm not going to attach that 4 on there. That's not what I'm trying to get rid of. I'm only trying to get rid of that radical. So I'm just going to multiply by that radical. In my numerator, I have square root 3 times square root 2, which gives me square root of 6. I'm going to multiply my coefficients in the denominator, giving me 4. And then square root 2 times square root 2 gives me 2. Simplify it one step further by multiplying 4 times 2. And my final answer is square root 6 over 8. Okay, that's all I have for you today. If you have any questions about these problems, please let me know. I am here to help. Okay?